So the tools we're going to be using in this task is the periodic table, our table of polyatomic ions, and we're also going to be using an ionic charge table that shows us the charge of various elements. So the first thing we have to do is figure out the chemical formulas for both of our reactants. Sodium on the periodic table is Na, and sulfide is sulfur, and that's S. And looking at our charge, our table of ionic charges, we can see that sodium has a +1 charge and sulfur has a -2 charge. So in order to get these to balance, we're going to need 2 sodium, and that will give us a +2 charge, and that will balance out. So we'll have Na2S. Next, we have iron 3 nitrate. So iron on the periodic table is Fe, and nitrate is a polyatomic ion. So we know that it's NO3. Now, this tells us that iron in this instance has a charge of +3, and we know that nitrate has a charge of -1. So we're going to need 3 nitrate to balance this out. So we write it as Fe parentheses NO3, 3. So in order to figure out what kind of reaction is going to take place here, we want to look at the properties of our reactants. So both of these are ionic compounds. We have a metal and a non-metal. And again, we have iron as a metal, and nitrogen and oxygen are both non-metals. So these are ionic. So we have sodium, which is a cation, meaning it has a positive charge. And then we have sulfur, which is an anion, which has a negative charge. And then similarly here, we have iron, which is a cation, and nitrate, which is an anion. Because of these properties, I think we're going to have a double replacement reaction. A double replacement reaction occurs when 2 ionic compounds, such as these, exchange their positive and negative ions to form 2 new compounds. So we have positive and negative ions. So the general form of a double replacement reaction is AB plus CD yields AD plus CB. So in this formula, A and C are our cations, our positive ions, and B and D are our anions. So using our double replacement formula and our reactants, we can identify that A is going to be sodium, our first cation. B is going to be sulfur, our first anion. C is going to be iron, our second cation. And D will be nitrate, which is our second anion. And when we follow this formula of AD plus CB, that gives us NaNO3 plus FeS. We're not completely done because we need to make sure the charges balance on all of these. So looking at our ionic charge table, we can see that sodium has a charge of +1, and our polyatomic ion table tells us that nitrate has a charge of -1. So this actually balances out by itself and can stay the same, NaNO3. Iron in this equation, or this reaction, has a charge of +3. And on our charge table, we can see that sulfur has a charge of -2. So in order for this to balance out, we're going to need 3 sulfur, which will give a -6 charge, and 2 iron, which will give a +6 charge. So that will balance out. So now we have our products. So now we're going to write the product names using the chemical formulas that we have. So we have Na, which is sodium. We have NO3, which is the polyatomic ion nitrate, plus Fe, which is iron, and S, which is sulfur. We're going to write a sulfide. And we know in this instance, the iron has a charge of 3, so it's iron 3 sulfide. And this also helps clue us in, if we didn't notice in the chemical form, that this is a metal sulfide, and that means that it's non-soluble. So this reaction is going to have a precipitate. Most metal sulfides are non-soluble. There are exceptions, but iron is not one of them. Okay, so now we can create our word equation for this reaction. And I couldn't fit it all on one line, so you want to make sure that you keep your reactants on one side and your products on the other. So we have sodium sulfide aqueous plus iron 3 nitrate aqueous, and that yields sodium nitrate aqueous plus iron 3 sulfide solid. So the last thing we need to do is to balance this entire chemical equation. So I've written it out in full at the top, and the way I like to do this is by writing out each of the elements or ions and how many are in each side, the reactants and the products. So I've just done it in order of how they appear on this side. So we have 2 sodium, 1 sulfur, 1 oxygen, and we have 3 nitrate. And for polyatomic ions, we balance them as 1 particle instead of breaking them down into the elements. On this side, I've just gone in the same order so I can read across. We have 1 sodium, 3 sulfur, 2 iron, and 1 nitrate. So now we just need to start balancing out both sides by changing the coefficients. I'm going to start with our nitrate, and instead of making balancing it out right away and making it 3, I'm actually going to put 6 here so that we can create even numbers, which will make it easier to balance out our other elements in the future. So now that I've done 6, we have 6 nitrates, and we also have 6 sodium. So we still haven't balanced anything yet. The next thing we're going to do is balance out the sodium. So there's 2 right now. We're going to add a coefficient of 3. And that will give us 6 sodium. So now these have balanced. It's also going to affect the sulfur that we have. So currently we have 1 sulfur, and that will give us 3, which is actually going to balance it out. So the last 2 we need to balance is our iron and our nitrate. So we can simply put 2 coefficient for this, and that will give us 2 iron and 6 nitrate. So now we have 6 sodium on both sides, 3 sulfur on both sides, 2 iron on both sides, and 6 nitrate on both sides. And that gives us our final equation of 3 Na2S, and that's aqueous, plus 2 FeNO3, 3 aqueous, and that yields 6 NaNO3 aqueous plus Fe2S3, and that's a solid. So that's our balanced entire chemical equation.